Unit 4, Lesson 2, Investigation 2, Sum of Squared Residual. So the first thing on our note says errors are the same as what's? Okay, when I say error, what am I referring to, now?
An outlier.
An outlier. What? The residual. Caleb, you were right. Okay. Errors are the same as residuals. All right. If you want to know why, remember in some of your science classes, maybe back in like middle school or maybe freshman year, where you calculate the percent error in a calculation. You guys ever do that before? Percent error? You've never done that? Okay, Jamaria says yes. Right?
Oh yeah, percent
So,
error. We do that in
in chemistry, right? When you do percent error, you have a predicted value that you get from stoichiometry, right?
Yeah.
And then you have an actual value that you get when you actually do the experiment, right?
Yeah.
To find percent error, what do you do?
The accepted value
minus
over.
accepted divided by accepted.
I was saying it in the times 100.
Okay. So, accepted value minus predicted value divided by accepted value times 100, right?
What?
So
Okay.
it's just something
And-
times something times 100.
All right, but basically, it's the, guys, the error, Jasmine, stop talking. The error is the difference. The is spelled T-H-E.
Just says non-residual.
The difference.
We wrote it down.
Yes. The error is the difference between the actual and predicted
Okay, put my back where it
values.
Oh,
So,
hey, McBride.
What?
We need one of these.
You need another one? They're actually back in the folder for Thursday.
All right.
In the white crate. Okay. So, error is the difference between the actual and predicted value, right?
Is that a B and a
V/N means between. Spend that way all year. Okay. Well, I do V/N. Some do V/N.
Usually we get rid of during handwriting.
Usually. I can read it.
Sometimes.
We were comparing your handwriting to Mr. Lincoln.
Messy handwriting is fast lines.
Okay. Now, you might remember residual. What does residual mean? What's the equation?
Is it
Um,
Caleb.
The actual
The least squared value.
Nope.
minus
Actual.
Wait,
Oh, sorry.
no, it's the other way around. It's predicted.
She got bloody nose.
Predicted minus.
Go to the bathroom.
Just go. So,
predicted minus-
actual. Actual y.
No, not.
Just he can go to the bathroom. He needs to. Okay. Actual y minus what? Okay, back to here, guys. Actual y minus predicted y.
You know,
This
Lily
is
being
so-
slow yesterday. She would not-
So, Alexis, Jasmine, what part of not talking do we not understand? Okay, that's the second time in like 2 minutes I've had to say your name. Okay, stop talking. It's easy. Okay, so residual is actual y minus predicted y, right? That's an equation we know previously. Okay, from other courses, Wesley was telling us about his chemistry class, right? Where they figure out the percent error. He said that they do the accepted value minus the actual value divided by accepted. Is that wrong, Katrina?
Yes.
Which way is it then?
It's accepted value over your error. Oh no, I'm trying to get percent error. I don't know.
You gotta do the subtraction. So it's accepted minus.
Accepted minus experimental divided by accepted.
And then
Okay.
Times 100.
Divided by accepted, right?
Accepted minus expected.
Times 100. Accepted minus experimental.
It's experimental.
That's
Like you actually do the experiment. Okay?
and you
So-
want it to be a low.
This is percent error, that's why you multiply by 100. Okay? Now this right here is the error,
Your
Okay.
residual.
which is essentially the actual, which is like our accepted, the actual value, okay, minus our predicted value. So,
experiment.
What we're learning right now with these data collection kind of goes along with what you do in your science classes when you are figuring out percent error. Does that make sense? Now, the sum of squared residuals. Okay? Oh, it's not residuals.
Oh my god.
Just say them.
Hey, who was in my science class in fourth Serena.
Guys, shh, Austin,
Sorry,
thank you.
No linker with me.
Okay. Sum of squared errors. The reason I erased it is because on your paper it says sum of squared residuals, Christian.
I know.
So I didn't want you to get confused.
I know.
There's sum of squared errors. Right? Also called SSE. Okay. Now, if I say sum of squared residuals, it means the same thing because residuals and errors are the same thing. Okay. Now, if I have a data set, Serena, stop talking. Thank you. If I have a data set, it's not in because it's a data as a consonant, not an adjective, not a vowel. So it'd be a data set. Okay. If I have a data set and I draw a line of best fit through it, the residuals are the distance each of these points are from that line of best fit. Right? Does that make sense?
Yeah.
All these residuals are negative. All these residuals are positive. Okay? Now, if I square my residuals, what happens to these negative ones? They become positive, right? If I square my negative residuals, those residuals become positive, don't they? So when I drew this line of best fit in there, if it is the line of best fit, all those residuals will add to what?
1, 0.
0. All those residuals will add to 0. Now if I square them all so I no longer have negative, when we add them up, what happens? Do I have 0 anymore? No, we could have what type of number?
Any number.
Any number, but it would be
Positive.
a positive number. And that's where the sum of squared errors comes in. Okay? The sum of squared errors is basically what it sounds like. Sum means
The addition of
addition of square residuals. Okay? So we'll get a number that's bigger than 0. And by saying, well, if we're worried about this in our residuals, how do they kind of go together? Well, every data set, when you add up all the residuals, they'll add to 0, right? Regardless of how close the data points are to that line of best fit. Right? Does that make sense?
Mhm.
Okay. Now, some lines of best fit are better than others. And that's where the sum of squared errors comes in. The smaller the sum of the squared errors is, the closer it is to 0, the better the line fits the data. Okay? So the closer the sum of squared errors is to 0, the stronger the relationship. It's kind of like the correlation coefficient. All right, does that make sense? Okay. So the reason why this is important is because we can see how close the actual data is to that line by figuring out the sum of squared errors. Right? So basically, sum of squared errors, we can just think of it as this. It is how far the data in the scatter plot is from the regression line. How far the data is from the regression line. Does that make sense? Pretty straightforward? Okay. Now the closer the data is to the regression line, what does that mean? Is it a good fit or bad fit? Good fit. If this data is closer to the regression line, if I add up all the squared errors, will it be a big number or a small number? Small number. So smaller SSE equals better regression. And part of the process that your calculator goes through to figure out the regression equation is it calculates the sum of squared errors for a bunch of different possible regression equations and picks the one with the smallest one. Right here? Right here? Yeah, it's just small. Oh, it's an arrow. That's a terrible arrow. No, my arrows were on trial. Any questions? Any questions? Anybody?
Yes.
What's that?
Hold on, I gotta copy this down so you can talk.
I don't even say.
Oh, hold on.
You know, when you
Okay,
make these,
so when you do
you should put lines.
The actual minus the predicted over the actual. That's what she was saying.
Yeah, that's
Those like,
Times 100.
that's not that's for chemistry.
That was like
Okay.
Which is
I was
me mixed up.
I was tying that error business they do in chemistry to the error stuff we're doing here.
Okay, so that has nothing to do with this class.
Similar things.
because you're still minusing it.
That's percent error. You're taking actual and experimental value and subtracting them. Okay. Here we're not doing an experiment, but our actual value is kind of like the experimental data,
So actual like.
and our predicted is with the equation. So we're kind of doing the same thing as that error calculation.
But we're just doing actual minus predicted.
Right. We're not finding percent error. I'm not dividing to figure out the percentage I'm off. Okay. I'm just figuring out how far we are from
So the
the
equation just says actual minus predicted.
Right.
You were on
What?
No, actually, no. The percentage would be like constant, like
I
zero.
saw like my grade notes.
The sum of all the percentages?
No, the sum is up zero, right? So when the sum of the percentages is like
I don't know. I never thought about percent errors and residuals.
alright, we'll do it.
Not right now.
We're not.
You can try it
It's
too.
important. It's like a
I know.
mathematical discovery right here.
But there isn't an actual. There isn't. Like, it's not like chemistry where we have an actual point. Okay. This is all kind of made with that. Now we could, Alexis, Jasmine, stop talking. Okay. We could divide this by the actual, then multiply by 100. Okay. Divide by the actual data set, or we could divide by the predicted, multiply by 100, and actually figure it out the same way. I'm guessing if all of our residuals add to 0, then if we were to figure out our percents, you're divided by the actual number every time, then they probably all add to 0. That's just a guess. But we don't really go into that in math with the percent error. That's more of a chemistry thing. Alright? So we can try one, Leslie, if you want to. If you're going to try to work on it, we can try one.
Mr. Range, how do you find the residual again?
Residual, the actual y minus predicted y.
What's
So-
the actual again?
That's the data they give us,
Is the actual?
is the actual, and the using the equation is the predicted.
Try those out.
Alright, we'll get some practice right now. Okay, so you guys have this worksheets.
No, we don't.
Yes, you do. It's right in front of you, Christian.